So in 2.9, we're definitely going to go a little bit more in depth, and some of these problems will be a little bit more complicated than what we've dealt with in other quadratic problems. So the first thing we need to consider is just talk about intercepts for a minute. We've talked about this earlier, but other name for your intercepts, especially x-intercepts, we could call them x-intercepts, we call them roots, solutions, or zeros. And just kind of be aware of that verbiage as we go forward with this section. You have three possibilities when dealing with a quadratic function. You could have no x-intercepts. You can see that this is never going to cross this x-axis. You could have it where it touches once, or you could have where it crosses twice. So we do have the possibility of 1, 2, or 0 intercepts. So let's just kind of review and remember how to find intercepts. At its basis, you're going to replace your y with 0 and solve for x. If you're looking for the x-intercepts reversed, you're going to have to replace x with 0 and solve for y. Now, when we're finding these x-intercepts, we do need to remember we are working with quadratics. So when we're solving quadratics, we're going to have to remember our factoring skills or possibly our quadratic formula, especially in application problems, because in real world, the numbers don't always come out to 2 and 4. So let's just kind of go forward here and see what we can do with these two intercept problems. It says find the x and the y intercepts of the following quadratic. So the first thing I'm going to do is I'm going to find the y-intercept. In order to find the y-intercept, you're going to set x equal to 0. So I'm going to say 3 times 0 squared plus 5 times 0 minus 2. So these both go away because they were 0. And so it just gives me y to be negative 2. Now, if they had me to write this answer as a point, I might need to write 0, negative 2. Just make sure you follow the instructions when you're writing out the answer. Now, to find my x-intercept. To find my x-intercept, I'm going to set my y equal to 0, and then I'm going to solve from there. Because we're dealing with a quadratic, we could possibly either factor or quadratic formula. And we're going to get a lot of practicing with quadratic formula in this section. So I'm going to do this one by factoring. If your lead term is a number other than 1, you can multiply these two together, and that would give me negative 6x squared. And then I could think, what'll give me negative 6x squared? So it could be negative 1x and 6x, negative 2x and 3x. And then I think, what will add to give me 5x? And that would be this negative 1 and 6. So I can split this one. I get 0 equal to 3x squared plus 6x minus 1x minus 2. The whole reason I want to split that because now I can factor by grouping. So in the first piece right here, I could factor a 3x out, leaving me with x plus 2. In the back half, I could take a negative 1 out, leaving me with x plus 2. And then I can pull that grouping x plus 2 out, leaving me with 3x minus 1. You could have done quadratic formula. You're still mathematically correct, but I want to make sure we cover this to help us. Then you just solve both those equals 0, so you get x to be negative 2. 3x minus 1 equal to 0 gives you 3x equal to 1, so x equal to 1/3. And so what are my two x-intercepts in this one? It'd be negative 2 and 1/3. Again, if they wanted you to write them as ordered pair, it'd be negative 2, 0 and 1/3, 0. So not too bad. Let's do the next one. Find the x-intercepts of the quadratic function. So I mean I have to set my function equal to 0 and solve. I get 2x squared plus 4x minus 4. And I think, you know what, they all have a 2 in common, so let me factor a 2 out. I like to try to factor before I run to the quadratic formula because sometimes it can be less steps. But when I get to this step, I see when I try to factor, and I think what'll multiply to give me negative 2, but add to give me 3, this doesn't work out. So I cannot take the factoring approach. So I'm going to have to remember my quadratic formula. If you struggle with remembering the quadratic formula, if you will go to YouTube and Google quadratic formula in there, they have some really annoying but good videos on how to remember it. So remember when you're doing quadratic formula, you want to identify your A, which is 2, B, which is 4, C, which is negative 4, and then you want to plug in your values. I always recommend kind of writing your formula with blank parentheses everywhere. Some of you on your last exam did not have the quadratic formula correct. So it doesn't show me that you could use the formula. It told me that you weren't sure where to start with the formula. Plug in all the letters you know. So B is 4, A is 2, and C is -4. Remember, when you're plugging in the quadratic formula, we're only using the coefficients. We do not use the x squared or the x. So from there, I can just clean it up. So this gives me -4 plus or minus the square root of 16 plus 32 all over 4. Remember, you can only use a simpler scientific calculator, so I would not by any means type all this in. I wouldn't even type in all of this. I would go to my calculator and I would type in just this grouping right here and get your answer. So this gives me -4 plus or minus the square root of 48 all over 4. You square root 48 and it gives you a decimal, so we're going to have to break it down like we've done in similar videos. So this would be 4 and 12, 2 and 2, let's see, 4 and 3, 2 and 2. So the square root of 48 would be equal to the square root of 2 times 2 times 2 times 2 times 3. Since I have two groupings of 3 that could come out front, I could say x is equal to -4 plus or minus 4 square roots of 3 over 4. Now, many of you will try to divide the 4 and the 48, and I cannot do that because it's being blocked by this radical. But having a 4 out front, I can now say -4 over 4, which is -1, plus or minus 4 over 4, which is 1, so square root of 3. So what are my intercepts for this function? I could have only found them by doing them a quadratic formula, and they're x equals -1 plus or minus square root of 3. Depending on how they want you to answer, you may have to go to your ordered pairs, and you will have to separate them because you will not find this plus or minus symbol within your calc pad. So, a little bit more intense with finding that intercepts. Just go slow, use your formula, use your calculator as need be. Don't try to do it all in one swoop and get your final answer. I like nice answers like this, not rounded decimals. Let's do a last one. Find the x-intercepts of the quadratic function. So again, we're going to set it equal to 0 and solve. Now with this one, you're thinking, okay, well, let's see if we could factor it. I mean, I absolutely would start there. Now the back sign is positive, so it means it's going to be the same. And they're both going to be this sign. And then I think, what will multiply to give me 3 and add to give me 2? Well, only 1 times 3 will give me 3, but that doesn't add to give me 2. So this doesn't factor. I wish it would have. You could see from that previous example, it goes pretty quickly. So again, I'm going to have to do my quadratic formula. -b plus or minus the square root of b squared minus 4ac all over 2a. So let's identify our a's and c's. A is 1, b is 2, c is 3. So I have -2 plus or minus the square root of 2 squared minus 4 times 1 times 3 all over 2 times 1. Again, in using your calculator, I would only type in this piece right here. Step some. So this gives me x equal to -2 plus or minus the square root. And when you type all of this into your calculator, you get -8. Now, in previous lessons, it might scare us to get -8, but now that we know complex numbers, we know that that is equal to -2 plus or minus 2 square roots of 2i. Again, you take that 8, you break it down, and that's the same thing as the square root of 2 times 2 times 2. So you have one pair you can bring out front. The I comes from the negative over 2. Now that I have a 2 out front, I can reduce both of these. So this gives me -1 plus or minus the square root of 2i. And so that is the x values that would give me a 0 for the y. Now in terms of intercepts of where is this quadratic crossing my x-axis, it is not crossing the x-axis because this is an imaginary number, and we cannot graph an imaginary number on the real plane. So this actually gives me no x-intercepts, although we found a solution with the quadratic formula. So just be aware, although I can complete it now with the use of imaginary, in terms of graphically, it is no x-intercepts. So I wanted to specifically show you this example because it's an example where you do get two solutions, but they are imaginary, so graphically they will not work out. For the next example, I hope I haven't scared you too much here at the beginning. There is a lot of quadratic formula in this one because when I go into application problems, in the real world, everything doesn't end and stop at 2 and 4 seconds, or everything doesn't exist at these really nice factorable numbers. And so when we're trying to apply to the real world situation, real world is not going to be perfect numbers. You're going to get decimals, you're going to have fractions. And so I'm going to work some of those with you. The key to working these application problems is to understand what you're looking for graphically so that you can use your information of quadratics to help you to complete that. And so hopefully we can go slow and then the homework will be manageable because we have some similar questions to help you with that. Now, anything we do in the notes or the homework is free game for the exam. So if you don't understand something, you need more explanation, please contact me because I do want you to do well in the homeworks, in the practice, and the exam. So a ball is thrown upward from the top of a 40-foot high building at a speed of 80 feet per second, and the ball's height above the ground can be modeled by this equation. So with any application problem, I like to kind of think about it and say, okay, so here's a building. It's from the top of a 40-foot building. A ball was thrown upward, so it's thrown up, and then it's going to come down. And it says, when does the ball reach the maximum height? So if I extend this down, this kind of looks like a quadratic. Max height would be occurring here, so that would be at my vertex. And so pictorially, I have my building, it's being thrown up, then coming down, and where is that max height? So I'm thinking vertex. So here's my function, and this was given in the problem. So to find the vertex, remember we're going to have to do x equals negative b over 2a. My a is negative 16, b is 80, and c is 40. So I'm going to say equal to negative 80 over 2 times negative 16. So that gives me 5 over 2, just using my calculator to help me with that. Now this tells me xy is 5 over 2. So when does the ball reach max height? 5 over 2 or 2.5 seconds. And again, a picture helped me to see that graphically I'm looking for the vertex. Now what is the max height? That's going to be the y value of this. So in order to find the corresponding y value, we do, so this is part B, h of 5 over 2. So that's negative 16 times 5 over 2 squared plus 80 times 5 over 2 plus 40. Go in your calculator and let me kind of show you what this looks like as I'm punching in. Remember, only a simple or scientific calculator. So it'd be negative 16 times 5 over 2. I always keep my fractions in parentheses here. Squared plus 80 times 5 over 2 plus 40. And that gives me 140. So what is the maximum height of the ball? 140 feet. When does the ball hit the ground? Well, notice it happens here and here. Well, this is if I backtracked it. So graphically, that point there is an x-intercept. So really drawing a picture is very helpful for me to realize what is the math behind this problem. So when does it hit the ground? I'm going to have to solve this for 0. So I'm saying negative 16t squared plus 80t plus 40. I'm going to tell you, factoring something like this, it doesn't work out with these numbers. And so I'm going to say negative b plus or minus the square root of b squared minus 4ac all over 2a. And that'll give me my intercepts. And again, we'll have to figure out this one. Graphically, this one would be negative, and time can't be negative. And so I am going to have to void out one of my answers. And so I'm going to say negative, and I'm using these a, b's, and c's I already have here. So I'm going to say negative 80 plus or minus the square root of 80 squared minus 4 times negative 16 times c, which is 40, all over 2 times negative 16. Again, only plug this piece into your calculator. So I'm going to say 80 squared, 80 squared minus 4 parentheses negative 16 and then 40. I do not want to type all this in. I just want to get that number underneath. So this would be equal to negative 80 plus or minus the square root of 8960 all over negative 32. Now use your calculator. So I'm going to do the square root of that answer. I'm going to do negative 80 plus that answer, divide it by negative 32. So that gives me an answer of negative, I like 3 decimal places, so 458. So that was the addition. I'm going to do the subtraction now. So I'm going to come back over here and I'm going to say negative 80 minus the square root of 8960, hit enter, divide it by negative 32, enter. And again, I'm around to 3 decimal places, so 5.458. So this negative one is back here because mathematically it had 2 intercepts, but since it's coming from a building coming down, the positive answer is the only one that I really need. So when does the ball hit the ground? After 5.458 seconds. So mathematically, we did vertex and intercepts. Real life, this helps me to see the maximum height, how long until it reaches max height, and when does the ball hit the ground. So the hard thing about this is first interpreting where you want your answers from. A picture helps. And then 2, just the details of the numerics. Let's do something else. Let's look at this one. Marcus wants to build a rectangular enclosure for his animals. One side of the pen will be against the barn, so he needs no fence on that side. So I'm going to draw a picture. So here's the barn. And he wants to build an enclosure here. If he has 700 feet of fencing is what goes all the way around, so that means my perimeter is going to be equal to 750 feet. You can find the dimensions that maximize the area of the enclosure. So I'm wanting to maximize it, so we're probably going to have to use our vertex with this. Let W be the width of the enclosure perpendicular to the barn. So if here's the barn, here's the width, so this is a width. And L will be the length of the enclosure parallel to the barn. So this side's parallel, so that would be my length. Write a function for area of the enclosure in terms of W. You can see A of W. Hint, first write 2 equations with W and L and A. Solve for L. Okay, so here's what we know. We know that for the perimeter is going to be twice the width plus the length equal to 750. I'm not saying twice the length because that's one side of the barn. I know that area is going to be equal to width times length. Since I know my formula needs to be area in terms of W, I'm going to work with this equation here and solve it for L. So I'm going to say subtract 2W. And L is equal to 750 minus 2W. So I'm going to substitute that into my area formula. So I get the area with relation to W is equal to W times 750 times 2W. I'm going to distribute. And I get 750W minus 2W squared. And so that's going to be my first blank. 750W minus 2W squared. Now make sure you're using W's and not X's because it'll mark it wrong because it thinks it's a different variable. What width would be maximum area? And what is the maximum area? So again, maximum, we need to be thinking vertex. And so I'm going to solve this for vertex. Remember, vertex is x equals negative b over 2 times a. Now if I line this up, this says that a is negative 2, b is 750, and c is 0. So I'm going to say negative 750 over 2 times negative 2. So I get negative 750 over negative 4. And then, move this up. When I divide this, this gives me 187.5. Now this is in relation to my W, my width. So what width is maximum area? It would be 187.5. It's important that you set up the barn the way it mentioned with the perpendicular and the parallel, because if you had not, you may have accidentally gotten the length and be plugging in the wrong value. Now what's the maximum area? Area is a Y value. So I'm just going to plug in 187.5 in here for W. So I'm going to say A of 187.5 is equal to 750 times 187.5 minus 2 times 187.5 squared. Use your calculator, and that gives you 7,031.5 feet squared. So it would be 7,000, excuse me, I don't need a comma right there when I'm typing it in, 7,031.5. So again, mathematically, you're just finding vertex. The difficulty is this part right here, but a picture is very helpful. So think about, what do you know, what can you pull out, and what are you looking for? So I hope this kind of helps with that. Again, the picture is so helpful, and then getting to this, once you get your area equation, the rest of it is not too bad, but this is a little bit difficult getting that first part. But we're in college. We're learning college algebra, not middle school algebra, high school algebra. So we can do this. Last problem. The demand equation for a certain product is given by, so I have P equal 138 minus 0.05x, where P is the unit price of the product and X is the number of units produced. The total revenue obtained by producing and selling X units is given by R equal to X times P. So I'm going to have to do X. P is this, so I'm going to just plug that in here, 138 minus 0.05x. So my revenue function would be equal to distribute 138x minus 0.05x. Determine the prices P that will yield a revenue of $7,570. So I want my revenue equation to be equal to 7,570. And so, let's see, sorry, that should have been a squared. And so I'm going to solve this out. Whenever you're solving for a quadratic, you want to get everything over to one side and set it equal to 0. So I'm going to move these two pieces over here, so I get 0 equal to positive 0.05x squared minus 138x plus 7,570. Now with this one, we are going to have to do our quadratic formula. So I'm going to say negative b plus or minus the square root of b squared minus 4ac all over 2a. My a is 0.05, b is negative 138, and c is 7,570. Now if you move the 7,570 over, you just have difference of signs, but we'll still get the same answer. So let's see, negative and negative 138 plus or minus the square root of negative 138 squared minus 4 times 0.05 times c. Now I haven't shown you all the steps of plugging this in, but I do want to show you this one on your calculator because I want you to be careful. If you don't use parentheses appropriately, you're going to mess up this number here. So I'm just going to pop my calculator in the bottom here. Now I'm just going to plug in everything that's under that square root. So I'm going to say negative 138 parentheses squared. If you don't put this in parentheses squared, it will square the 138 and then add the negative, and it will really throw off your answer. Minus 4 times 0.05 times 7,570. And that gave me 17,530. So this would be equal to 138. That gives go together, plus or minus the square root of that number we just got, all over 2 times 0.05, which is 0.1. Now, just like we did before, you do 138 plus that square root, enter, divide it by 0.1, and 138 minus that square root, enter, divide it by 0.1, and you get the values of 55.99 and 2704.01. So going back up to our blanks up here, it says what is the lowest such price? That would be $55.99. I'm going to round to 2 decimal places because it's in dollars. And then my highest such price is going to be $2,704.01. So make sure you round appropriately. It is money, so 2 decimal places. So again, the mechanics of these problems is definitely a lot of quadratic formulas. But just make sure you take out the information that's given, see what you're working with, go slow, and seek help if you need it. Now, waiting till 10 o'clock on the night it's due, you're not going to have as much help. You can't guarantee that I'm going to be online at 10 o'clock right when it's due, but start on it early so we can correspond back and forth and get you the help that you need. I hope this goes well for you. Again, any of these problems can be free game on the exam.